All right, in the last video, we talked about the basics of what a sequence is, what a series is, and then we started talking about this arithmetic sequence. And remember, arithmetic is where you're adding a fixed amount to go from one term to the next. Now, we are going to talk about the different ways of writing a sequence. And so if you look up here, you can just write out the terms of the sequence, which a lot of times that's what you guys are used to. But what people do not realize is there are other ways that you could write it. There's two other ways that you could write a sequence. One of them is in what's called recursive form, which when it's written in recursive form, what that's doing is it's telling you what you do to go from one term to the next. And usually what I tell people is this is the way that we typically think. When we see a pattern of numbers, we automatically try to find the pattern. In other words, we try to find what am I doing to this number to get to that number? What am I doing to that number to get to that number? And we're trying to see, is there something that's happening over and over and over again? And that is actually what recursive is it's telling you what to do to go from one term to the next. Okay? So that is one way that you could write it, but it will be written in the form of an equation. Okay? So to be able to do this, you have to understand a little bit more with the notation that we were talking about in the last video. And so if you look up here, the notation for a general term in your sequence was the A with the little subscript of an N. Okay, so we're going to concentrate on that just for a moment. So if you're looking at a term in your sequence, so we're going to label it the way that it's supposed to be labeled with an A sub N. The term that is the next term will be the term, remember N is the position of your term, so it would technically be the term that's in the next position. So like think about that. If this was the fifth term right here, then this one right here would technically be the sixth term. Okay, so how do we write that with this same notation? Well, this would be the position, like this term right here would be the position right after that one. So this one, the way that you label that would technically be A with a little subscript of an N plus 1, because you have to add 1 to the position of your term. Remember, N is the position. Now, same kind of thing. If we go back one term, this would be like if that was the fifth term, then this would technically be the fourth term. So the position of that would actually be 1 less than whatever N is, okay? So that will come up whenever we start talking about the recursive form of these sequences, okay? So this would be your term, like your general term in your sequence. This would be the next term in your sequence, if you're kind of thinking about just your sequence in general. So the next term. And then this would be the previous term, the term right before this term. Okay, so this would be your previous term. Okay, so when we are writing a recursive form, it's going to relate, because it helps you go from one term to the next term. It's going to relate either this one, what am I doing to this term to get to that term, or it'll have something about what am I doing to this to get to that term. Okay, so like one thing that you may see is you could see something like that. They would have A sub N equals A sub N minus 1 plus 2. So if you see an equation like that, that is a recursive equation, because this, remember, this previous term, this is the term right before that one. So what this is actually saying is you are adding 2 to the previous term to get the next term. Okay, so this means that the pattern, you are adding 2 to go to the next term, or to get the next term, I guess. Okay, so that's recursive. Now, explicit form is a little different, and it's also sometimes called closed form, and so you'll need to make sure you're aware of that because I'm not sure how you may see it in the future, okay? But explicit form of a sequence is very different, and a lot of times it's a little bit different than how we think, and the reason for that is because it's actually based on the position of the term. Okay, and so a lot of times when we're looking at a sequence, we're not looking at the position of the term, we're just looking at what's the pattern, which is different. Okay, and so explicit forms, they're going to have, like with the equation, they're going to have an A with a little subscript of n most of the time, and then they're going to have an n somewhere in your equation. There's going to be just the n because remember n is the position of your term, and so that's the reason somewhere in your equation there will be an n. Okay, now the reason why we use the explicit form of a sequence is because recursive only helps you so far. Okay, explicit actually helps you a whole lot. It's actually useful when you have to find a term that is later in the sequence or find other things in the sequence, like if they ask you to find the first term of your sequence and they give you other information, or maybe they ask you to find the position of the term and they give you some information to do that. Okay, that sequence, the explicit form of that sequence, is actually very useful when they ask you questions. Okay, so what we're going to concentrate on is what is the recursive form of an arithmetic sequence, and then what is the explicit form of an arithmetic sequence. So both of these equations will be very specific to the sequence that we have been concentrating on. Okay, so when you have to write the recursive form, remember this is what you do to go from one term to the next. You're going to like find the term in your sequence. You're going to take and do something to the previous term. So remember, this is your previous term. Well, if you remember, so go back up here and look. With arithmetic sequences, you are adding a fixed amount to go from one term to the next. And the number that you're adding is called your common difference, which they label with a D. And so the recursive form to go from one of your terms, the previous term, to the next term, you have to add whatever that common difference is. And so that is the recursive form of an arithmetic sequence. And so the other thing that you have to actually also tell in an arithmetic sequence is one of the terms that are in your sequence. So usually people will tell the first term. It does not have to be the first term, but most of the time people will also make sure they tell the first term. And the reason for that is because if you don't tell the first term, it could actually end up with a totally different sequence. So like for instance, if I started a sequence with the number 2 and I was adding 3, that was the pattern. Like if I'm adding 3 to go from one term to the next, well, if I start with 2 and I add 3, the next term would be 5, and then the next term would be 8, and then the next term would be 11, and then we could keep going. Whereas if I start with a different number, let's say that I start with a number, I don't know, 10, if it followed that same pattern, well, the next term would be 13, and then 16, and then 19, and so on and so forth. That's a totally different sequence. And so that's the reason why you always have to give the first term, is you have to be specific, because remember, you're describing a sequence using these formulas. Okay. Now the explicit form of an arithmetic sequence, there is a formula for it that you will be given on the final exam. And this is the formula right here. They will actually give you a sheet that has this formula on it. You just have to know how to use it. Okay. So this helps you find any term in your sequence given certain information, obviously. So to find a term in your sequence, you take a sub 1, which remember is your first term, plus parentheses n minus 1. Remember, n is the position, and it's actually the position of this term right here. So it's n minus 1, and then you multiply that times d, which is your common difference. So remember, this is your first term. This is your position of your term. And then this is your common difference. Okay. So what we're going to do is we're going to practice when to use each of these formulas, and then we're going to practice how to use them. Okay. So I'll have to flip over for that. So if you need the other formulas later, I will give them back to you in just a little bit. All right. So the first thing we're going to practice is how to write the recursive form of an arithmetic sequence. Okay. So recursive form, remember, is what to do to go from one term to the next. So if I am trying to figure out the recursive form, the first thing you need to do is find the pattern. So I'm going to look at my sequence and I'm going to try to find what is the pattern to go from one term to the next. Well, to go from 4.5 to 5, it looks like I'm adding 0.5. To go from 5 to 5.5, I'm adding 0.5. Same thing there. So then my pattern is I'm adding 0.5. What if I did not realize that? Remember, you can always take one term minus the one before it, okay, and that'll get it for you. So if I have to write the recursive form, what am I doing from one term to the next? So to get a term in my sequence, I have to take the one right before it, that's how they write that, and I'm adding whatever that common difference is. So I have to add 0.5. Okay, and then remember, so I'm going to put a little semicolon here. You always have to tell a term in your sequence, and usually they'll put the first one. So it'd be a sub 1 equals 4.5. All right, so then the next one, same kind of thing. Got to find the pattern if I'm writing the recursive form. Well, let's say that I didn't know the pattern. I couldn't figure that out. Then all I have to do is take one of my terms. So I'm going to take 4. And I subtract the one right before it. And so when I do that, I get -5. So now I know I am actually subtracting 5 to go from one term to the next. So that's the pattern. So that's that part right there. Okay. So when I write my recursive form, to find a term, you take the term right before it, and then you subtract 5. Okay, because that's the pattern. And then remember, you always have to put one of your terms. So the first term in this sequence is 9. Okay, so that's practice writing the recursive form. To write the explicit form, there's actually kind of two ways that they accept answers usually with explicit form. So I'll show you both. For explicit form of an arithmetic sequence, you've got to remember the formula, and that's the reason why they give it to you. The explicit form is a sub n equals a sub 1 plus n minus 1 times your common difference. So to be able to put it in explicit form, you've just got to find all of these pieces of information, okay? The only thing that you don't plug into when you're just writing the form is you don't plug anything in for this, and you leave the n the way it is, okay? So like for this sequence, this is the same one we did before. The pattern, the common difference, was 0.5, so we already know that. And then when we're writing the explicit form, remember I said you leave the a sub n the way it is. You have to plug in your first term. So my first term is 4.5. That's where that goes. And then it's plus, remember the n stays the way it is, and then you multiply it times, well, my common difference was 0.5. Okay, so that is one way that you could write the explicit form. The other way is if you actually kind of simplified it. So for instance, if I notice this 0.5 is being multiplied times this. So what I'd have to do to simplify it is I'd have to distribute that 0.5, okay? And you only distribute it to what it's beside. So if I did that, I would get, all right, I'm just going to copy it over here. So we have 4.5 plus, if I distribute my 0.5, it would be 0.5 n and then minus 0.5. Okay, and then this is a like term with this, so I'm going to combine them. So when I do that, I would get a sub n equals, when I combine those, or actually I'd probably put the 0.5 in first. And then when I combine those, I get, well, 4.5 minus 0.5 would be a positive 4. And so This would be an answer you could get, or this would be an answer you would get. Okay, so now this one, same kind of thing. If I'm writing the explicit form, I have to find all of these bits of pieces of information. All right, so what's the pattern? Well, take 4 minus 9. You would get -5. So that's my common difference. And then when I plug it in, it's your first term, which is 9 plus, leave the n minus 1 the way it is, and then that's times my common difference was -5. Okay, so again, that's one way that you could have your answer. Or if you distributed your -5, it would be, I'd have 9 plus, and actually it'd be plus the -5n, and then -5 times -1 would be +5. And then from there, combine my like terms, so combine the 9 and the 5. I'd have -5n, and then 9 plus 5 would be 14. Okay, so that's just practice writing the formulas. Okay, so now you have to know what to do to actually use your formulas. All right, so I'm going to show you kind of 3 examples that shows you when would you rather use the recursive formula, when would you rather use the explicit, and why. Okay, so when you look at number 5, it's saying find the 7th term in the sequence. If it's asking you to find a term that's not very far down in the sequence, just think about it in terms of recursive, or the recursive formula, because remember, recursive just helps you go from one term to the next. So 7th term, well, I already know the first 4. All I have to do is just keep the pattern going, and I'll be able to find the 7th one. So just find the pattern. So remember, if it's not obvious, you can take one term minus the one right before it, so like 17 minus 20. So we get -3. So that means I'm subtracting 3. Well, 1, 2, 3, 4. That's the 4th term right here. So now all I have to do is go a few more terms and I'll have it. So we're just going to write it out. So 11, if I keep that pattern going and I subtract 3, I'd get 8. So that's the 5th term. If I subtract 3 again, I get 5. So 1, 2, 3, 4, 5, 6. I just have to go one more. 5 minus 3 would be 2. So my 7th term, the way that you write it, a sub 7, is actually 2. So there we go. So with this way, it's actually easier to think recursively. What am I doing from one term to the next? All right. But if you look at number 6, you'll notice that thinking about it recursively may not be a good idea. So if finding the 40th term is not as easy, this is one where you actually want to use the explicit form. Okay, so before we were just plugging it in to write the equation so that we could use it. Now we have to actually plug it in to use it. So if we're finding the 40th term, remember 40th is kind of like the position of the term. So that's your n. So your n, when you plug it in your equation, would actually be 40. And so now, think about your explicit equation. If we're using the explicit equation, we are finding the term in the 40th spot. So we're finding a sub 40. Well, that means we have to know the first term, which notice we know our first term is -6, plus n. Well, remember, we're finding the 40th term, so the n would be 40. It's the position of the term you're dealing with here. So it's 40 minus 1. And then you just have to find what is the pattern, what is the common difference, what's the number that's added each time. So again, if that's hard to find, just take one number minus the one before it. So like an easy one for me to do would be 8 minus 1. And so I get 7. So that means you're adding 7. And then from there, all you really have to do is just type it in your calculator, or you can simplify if you wanted to simplify first. This would be 39, and then you take 39 times 7, and then whatever you get there, you would add the -6. Okay, but then you should get 267 when you're done. So the 40th term, if we actually wrote this whole thing out all the way to the 40th term, it would end up being 267. Okay? So now the last types of problems that you might see are going to be ones where you have to actually use a formula in a clever way. Okay? And you'll see why I say that in a second. So this one says, what is the position of the term negative 18 in the following arithmetic sequence? So if they're asking you for something that's not like a term somewhere in your sequence, that's probably a good indicator you're still going to be using the explicit formula, but you just have to use it in a clever way. So we're looking for the position. So that technically means we're looking for what is in, okay? So I'm going to write down my explicit formula, and I'm going to show you how you can use this to solve that problem, okay? So we're looking for the position of this term. So whenever you're having to use this formula in a clever way, whichever term that they give you somewhere in your sequence, you can actually use for the a sub n. Okay, so since we're looking for the position of this term, that's the thing that I'm going to actually write down for my a sub n. Okay, that's the term that I'm dealing with in this problem. So now my first term, remember, is always whatever the first term is in your sequence, which is 12, plus, I knew that from looking right there, okay, plus n is the position of this term, which is what we're looking for. So we actually have to leave that the way it is. And then we just have to find the pattern. Well, what am I doing to 12 to get 7? What am I doing to 7 to get 2? And so you can either reason through it or you could subtract the two numbers. But if you reason, you would end up seeing that you're subtracting 5. So that's what goes in for your common difference. All right. So then from there, you just have to simplify. And we are trying to solve for n. Okay. So think about what I did up here when I simplified. We had to distribute that number. So I'm going to do the same thing here. I'm going to distribute my negative 5 to the n and the negative 1. So I'm going to bring this down. That comes down. Negative 5 times n would be negative 5n. And then negative 5 times negative 1 would be positive 5. Okay? And then when we have a plus and negative, that's actually just a minus. So I'm going to put a big minus under there. Okay? Now from there, we have like terms, so we need to combine those. So when I combine those, I'm going to bring the negative 5n up front, and then those get to be 17. And then I just solve. So to solve this, I've got to subtract my 17 from both sides so that I can get my n by itself. So then I end up having negative 5n equals negative 18 minus 17 is negative 35. And then all I have to do is divide by negative 5. Because this is negative 5 times n. So I have to divide by it to get it by itself, and then I get 7. So the position of this term, in other words, if I actually wrote this sequence out, this would technically be the 7th term in that sequence. So hopefully that helps. Just feel free to email me any questions you have or put it in the chat for the class. But good luck on the homework.